Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center, Yale. In the previous lecture, we discussed some points related to the frequency domain analysis, or it is the introduction part which is related to frequency domain analysis. Today, we are going to discuss how to develop this polar plot or the steps to develop the polar plot. So this is the introduction of polar plot. It is basically a plot which can be plotted in between the magnitude and phase of a particular wave. But these magnitudes are presented with the normal values. The polar plot is basically a plot which can be drawn in between magnitude and phase angle of g of j omega into h of j omega by differentiating g of omega from 0 to infinity. And the polar graph sheet is described here having the mentioned images. This graph sheet includes the various concentric circles and radial lines. The concentric circle and the radius lines are considered as a magnitude and phase angle. These angles are highlighted with the positive values in anti-clockwise direction and mask this angle with negative value in clockwise direction. So there are some rules for drawing or development or plotting of a particular polar plot. Let us see one by one. So first step is to substitute the S is equals to j omega, that is frequency domain analysis. We have to put the value of S as j omega in the open loop transfer function. After that, write down the expression of a magnitude and phase of g of j omega and h of j omega, means the production of this g of j omega into h of j omega. Now find the starting magnitude and the phase of g of j omega into h of j omega by substituting the value of omega is equals to 0. Then the polar plot will start this magnitude and the phase angle. Now the step is towards finding the ending magnitude and the phase of j omega into h of j omega by substituting value of omega is equals to infinity, so that this polar plot ends with the magnitude and the phase angle. Next step is check whether the polar plot intersects the real axis by making some imaginary terms of g of j omega into h of j omega equals to 0 and find the value of s, that is omega. Now we are moving towards whether the polar plot intersects with imaginary axis by making some real terms of g of j omega into h of j omega equals to 0 and find the value of s, same as above. For drawing this polar plot, find the magnitude and phase angle of g of j omega into h of j omega by considering the other values s of omega. Here we are taking one example. Consider this open loop transfer function of a closed loop control system g of s into h of s is equals to 5s into s plus 1 s plus 2 g of s into h of s, which is equals to 5s into s plus 1 s plus 2. So what is the first step? Yes, as described in this slide, substitute s is equals to j omega in open loop transfer function. If we put all the functions value s is equals to j omega, then we got the second line equation, so that the magnitude of this open loop transfer function is m is equals to, see this equation, so that the phase angle of the open loop transfer function is phi is equals to 900 minus tan inverse of omega minus tan inverse of omega 2. Here are the second step. This table basically shows the magnitude and the phase angle of the open loop transfer function at omega is equals to omega 0, right, per second, and omega is equals to infinity, and omega is equals to again infinity, rad per second. So this frequency, that is rad per second, and magnitude phase angle, that is degree, 0 to infinity and 90 degree, or 270 infinity, or 0 to 270 or 90 degree. While this polar plot will start at infinity to minus 90 degree and ends at 0 to minus 270 degree. The first and second term basically includes in the bracket, which shows that the magnitude and phase angle of particular polar plot. And last step is that as per the starting and ending polar shows that this polar plot will follow the negative real axis. The phase angle related to the negative real axis is minus 180 degree or plus 180 degree. And once you equate the phase angle of the open loop transfer function to either minus 180 degree or plus 180 degree, we will get the omega value as root 2. Now, change in the magnitude of the open loop transfer function, we will receive m is equals to 0.83 and n is equals to 0.83, so that the polar plot intersects the negative real axis when omega is equal to root 2 omega and it is equals to 2, and the polar coordinate is 0.83 and minus 180 degree. Thank you.